Okay, hi everyone. Welcome back to this live stream discussion on Windows Server 2000. So I'll just share my screen. Okay, Chapter 14: Advanced Windows 2000 Server Administration. Managing complex networks and infrastructure. Windows 2000 Server offers a rich set of administrative tools and features that help system administrators manage large and complex infrastructures. As organizations grow, so does the need for more sophisticated administrative methods. In this chapter, we will explore advanced administration techniques for Windows 2000 Server, focusing on tools and strategies for managing large scale deployments, complex networks, and high availability environments. The goal is to provide you with the knowledge and skills to manage enterprise level systems and networks, optimize your server infrastructure, and ensure that your Windows 2000 environment remains both stable and secure. 14.1 Advanced Administrative Tools and Utilities. Windows Server. Windows 2000 Server comes with a comprehensive suite of administrative tools that go beyond basic configuration. These tools allow administrators to manage network resources, automate tasks, and monitor system health across the organization. 1. Active Directory users and computers. Active Directory AD is one of the cornerstone features of Windows 2000 Server, providing centralized management for users, groups, computers, and network resources. The Active Directory users and computers ADUC tool is the primary interface for managing objects within Active Directory. Key features: user and group management. Create and manage user accounts, groups, and organizational units. OUs, password policies, configure password settings, and enforce security policies. Delegate administrative privileges to specific users or groups for delegated management of Active Directory resources. Advanced use cases. Group policy management. Use group policy to enforce security and configuration settings across the network. For example, you can enforce password expiration, user login restrictions, and desktop settings. Organizational units. OU organize users and computers into OUs to simplify the management of large networks. Active Directory sites and services. Use this tool to manage AD replication, manage site links, and control how Active Directory communicates across different locations. To Group Policy Management Console, GPMC. The Group Policy Management Console, GPMC, is another powerful tool in Windows 2000 that enables administrators to manage and configure group policy settings across multiple servers and workstations. Key features: group policy objects, GPOs. Create and apply GPOs to define security settings, software installation policies, and user configurations. Link GPOs and OUs. Link GPOs to specific organizational units or entire domains to apply configuration settings to users and computers. Group policy modeling. Simulate how a GPO will affect users and computers in a specific organizational unit. Advanced use cases. Group policy inheritance. Use inheritance to apply consistent policies across all users and computers within a domain or OU. Override default policies where necessary to apply exceptions. Security filtering. Apply group policies based on user or computer setting. Security groups enabling more granular control. 3. Event Viewer. The Event Viewer tool is critical for monitoring and troubleshooting Windows 2000 Server. It logs system events, application logs, and security events, helping administrators to identify and resolve issues. Key features: system logs, view logs related to operating system operations, hardware errors, and critical system failures. Security logs track security related events such as failed logins, privilege escalations and potential breaches, application logs, monitor the behavior of applications running on the server and diagnose any issues, advanced use cases, event log filters. Set custom filters to focus on specific types of events. For example, filter all failed login attempts or all system crashes log alerts. Configure Event Viewer to alert administrators to critical events or errors in the logs. 4. System Monitor. System Monitor, part of the Performance Monitor suite, is an advanced tool that allows administrators to monitor and analyze real-time system performance data. This tool can track system-wide performance metrics like CPU utilization, disk I/O, memory usage, and network activity. Key features: real-time data collection, track and analyze real-time performance data for various system components, custom data views, create customized data views and graphs to monitor specific system resources, logging, collect and store performance data over time for historical analysis. Advanced use cases, performance baselines, establish performance baselines to compare current performance data with historical trends, helping you identify potential system bottlenecks. Altering and logging, set up alerts to notify administrators when certain thresholds are exceeded, CPU utilization over 90%. 14.2 Server clustering and high availability. High availability HA and fault tolerance are essential for ensuring business continuity. Windows 2000 Server supports server clustering, which enables administrators to deploy high available services that can fail over in case of server failure. 1. Windows 2000 Cluster Services. Windows 2000 Server offers cluster services, which allows multiple servers to work together as a cluster to provide high availability for applications and services. Key features: failover clusters ensure that services running on one node in a cluster automatically fail over to another node in the event of failure. Shared storage clusters use shared storage, allowing both nodes to access the same data. If one node fails, the other can take over without any data loss. Cluster configuration, configuring cluster resources, including virtual servers, shared disks, and network names. Advanced use cases. File and print services clustering. Use clustering for services like file sharing and printing, ensuring that users can access shared resources even in case of a server failure. SQL Server clustering. Implement SQL Server in a cluster for database availability, ensuring that mission critical data is always accessible. DNS and DHCP high availability. DNS and DHCP services are critical for network management, and their availability must be guaranteed. Windows 2000 provides features that help maintain these services in a high availability setup. Key features: DNS load balancing. Distribute DNS requests across multiple servers to improve availability. DHCP failover. Configure multiple DHCP servers to ensure that clients can obtain IP addresses even if one DHCP server fails. Advanced use cases. DNS replication. Set up DNS replication between multiple DNS servers to ensure that DNS data is consistent and availability. DHCP server redundancy. Use multiple DHCP servers in different subnets to ensure redundancy and reliability. 14.3 Automating administration tasks. As environments grow larger and more complex, administrators need to find ways to automate repetitive tasks. Windows 2000 offers several methods for task automation. 1. Task Scheduler. The Task Scheduler utility in Windows 2000 allows administrators to schedule automated tasks such as backups, disk cleanup, and report generation. Key features: task automation, schedule regular maintenance tasks like server reboots, virus scans, or database backup. Trigger-based execution, set tasks to run based on specific triggers such as the time of day, system idle state, or after a user logs on. Script execution, used scripts, batch files, PowerShell to automate complex tasks. Advanced use cases, automated backups, schedule daily or weekly backups using Task Scheduler to ensure that data is regularly saved. Log management, automate log management tasks such as clearing old logs or archiving logs to remote storage. 2. Windows Scripting Host, WSH. The Windows Scripting Host allows you to write scripts to languages such as VB Script or JS Script to automate administrative tasks. Key features: automation with scripts. Write scripts to automate repetitive tasks like user account management, system checks, or server configuration. Integration with other tools. Scripts can be integrated with other Windows tools such as Task Scheduler or Event Viewer for extended automation. Advanced cases: use account provisioning. Write scripts to automatically create user accounts, set permissions, and configure user profiles. Server health monitoring. Use scripts to check server health parameters, e.g., disk space, CPU usage, and send alerts when thresholds are exceeded. 3. Remote administration with remote desktop. Remote administration is crucial for managing servers in a distributed environment. Remote desktop (RDP) allows administrators to connect to servers remotely and perform management tasks. Key features: secure remote access. Use RDP to securely manage servers from any location, reducing the need for physical presence. Multiple sessions. Multiple administrators can log into the same server simultaneously for collaborative management. Advanced use cases: administering multiple servers. Use RDP to manage multiple servers from a single workstation, making it easier to oversee large networks. Remote diagnostics. Use remote connections to perform diagnostics and fix issues without physically visiting the server location. 14.4 Managing large-scale networks. In large organizations with multiple servers, it is essential to have efficient systems in place to manage the network and ensure that all components are functioning properly. 1. Windows Management Instrumentation. Windows Management Instrumentation (WMI) provides a framework for managing and monitoring Windows-based systems. It allows administrators to query system information, configure settings, and automate tasks. Key features: system querying. Query system details such as hardware specifications, software installations, and software configurations. Remote management. Use WMI to remotely manage servers and workstations from a central console. Advanced use cases: automating system configuration. Use WMI scripts to gather information on system configurations and automate changes across multiple servers. Inventory management. Use WMI to create an inventory of hardware and software across your entire network. 14.5 Best practices for advanced administration. To ensure that your Windows 2000 infrastructure remains stable and secure, here are some best practices. Regular auditing. Regularly audit and review server logs and user activity to detect any unusual behavior. Centralized management. Use tools like Active Directory, Group Policy, and WMI to centralize management tasks and simplify administration. Documentation. Document all configurations, server roles, and network setups to ensure that you can recover from unexpected changes or failures. Testing and staging. Before applying major changes, test configurations in a staging environment to avoid disruptions in production. regular backups, implement and test a robust backup strategy to ensure that data can be restored in the event of a failure. So, summary: advanced administration of Windows 2000 Server involves managing complex network infrastructures, automating tasks, ensuring high availability and efficiently monitoring server health. Tools such as Active Directory, Group Policy, Event Viewer, and Windows Management Instrumentation (WMI) allows administrators to handle the needs of large enterprise-level networks. By utilizing these tools and following best practices, administrators can optimize their server environment, ensure security and reliability, and prepare their infrastructure for future demands. In the next chapter, we'll discuss troubleshooting and recovery. So here we are, Chapter 15, Troubleshooting and Recovery in Windows 2000 Server. Diagnosing and resolving system failures. Troubleshooting and recovery are vital aspects of system administration, especially for complex mission-critical server environments. In a Windows 2000 server setup, you may encounter various issues ranging from simple performance degradation to complete system failures. As organizations continue to rely on legacy systems like Windows 2000 for specific tasks, knowing how to quickly diagnose problems and recover from them becomes essential. This chapter will guide you through the key troubleshooting tools, techniques, and best practices for managing system failures, performing diagnostics, and ensuring data integrity during recovery process. 15.1 Introduction to Troubleshooting. Troubleshooting in Windows 2000 requires a systemic approach to identify and resolve issues. Whether you're dealing with hardware malfunctions, software errors, or network connectivity problems, having a consistent method will allow you to narrow down potential causes and apply the appropriate fixes. Common types of issues: system performance or problems, slow server performance, high CPU usage or disk space issues, application crashes, programs or services crashing unexpectedly, network connectivity problems, issues related to networking, DNS resolution or domain communication, hardware failures, disk, memory, or other hardware-related issues, security breaches, unauthorized access, malware infections, or compromised accounts. Troubleshooting can generally be broken down into these steps. Identify the problems. Gather as much information as possible about the issue. Isolate the cause. Use diagnostic tools and logs to pinpoint the root cause. Resolve the issue. Apply the appropriate fix, whether it be updating drivers, patching software, or modifying configurations. Verify the solution. Ensure the issue is resolved and that the system is stable. 15.2 Key tools for troubleshooting. Windows 2000 provides a suite of tools to help troubleshoot issues across various layers of the operating system. Here are some of the most important utilities and their applications in troubleshooting. 1. Event Viewer. The Event Viewer is a crucial tool for monitoring and diagnosing system issues. It logs events that occur in the system. Application and security logs allow you to track down problems such as errors, warnings, or system crashes. Key features: system logs, log system level events including boot issues, driver problems, and hardware errors. Application logs, track application errors, crashes, and unexpected shutdowns. Security logs, logs security related events such as login failures or unauthorized access. How to use: identify error codes. Look for specific error codes in the logs to correlate with known issues. Filter events. Filter logs to isolate events by type, e.g. a warning, error, or by specific time frames. Event details. Click on an event to get detailed information about the error, including potential causes and resolutions. 2. System Performance Monitor. The System Monitor tool helps track system performance in real time. It allows you to monitor CPU usage, memory utilization, disk I/O, and network activity. Key features: real-time monitoring. View real-time performance data to identify bottlenecks or resource-heavy processes. Data logging. Store performance data over time for later analysis. Customizable counters. Choose specific performance counters. CPU usage, disk latency to track based on the problem you're diagnosing. How to use. Identify resource issues. Use Performance Monitor to detect resource spikes such as high CPU or memory usage that could indicate system performance issues. Compare historical data. If possible, compare historical performance data to identify trends and pinpoint where the problem started occurring. 3. Device Manager. Device Manager is used for diagnosing hardware issues. It provides a list of all installed hardware and their current status. Any hardware-related issues such as missing drivers or conflicts are displayed here. Key features. Check device status. Look for yellow exclamation marks indicating hardware issues. Driver management. Update, disable, or uninstall faulty drivers that could be causing problems. Hardware resource conflicts. Diagnose conflicts related to IRQs, memory addresses, or other resources. How to fix hardware issues. Right-click on any device with an issue. Choose to update the driver or troubleshoot the device. Identify conflict. If two devices are conflicting for the same resource, resolve the conflict by manually assigning different resources or updating the driver. 4. Task Manager. Task Manager allows you to monitor running processes, system performance, and the applications consuming resources, especially useful when troubleshooting performance issues such as when a specific application or service is using excessive CPU or memory. Key features. Monitor our running processes. Identify which processes are consuming excessive system resource and end unresponsive tasks. End unresponsive applications or processes that are causing the system to slow down. Resource usage. View system resource usage in terms of CPU, memory, and disk I/O. How to use. Identify problem processes. Sort the processes by CPU or memory usage to identify which programs or services are consuming excessive resources. Terminate unresponsive processes. If an application becomes unresponsive, use Task Manager to terminate the process and resolve the issue. 5. Command line utilities. Windows 2000 includes several command line utilities that can help diagnose in resolving issues. So I just want to make a click here. So key issues. CHK disk. The check disk utility scans and repairs file system errors and bad sectors on disks. SFC system file checker. This tool checks and repairs corrupted or missing system files. NetStat, a network utility that displays active connections, helps identify network related issues. IPconfig, used for diagnosing networking issues and viewing IP configuration details. Performance problems are among the most common issues that Windows 2000 server administrators face. These problems can arise due to insufficient resources, improper configurations, or software conflicts. Here's a breakdown of common performance problems and how to troubleshoot them. 1. CPU overload. When the CPU usage is high, it can slow down server performance and impact user experience. Steps to diagnose. Use Task Manager to check which processes are consuming the most CPU. In Performance Monitor, check the processor time counter to see if the CPU is constantly at or near 100%. A common causes resource-heavy applications running simultaneously, malware or malicious software consuming CPU resources. Solutions: terminate unnecessary processes using Task Manager, update drivers and applications to the latest versions, run an antivirus scan to ensure there is no malware. 2. Memory issues. Memory-related problems often manifest as system slowdowns, particularly when RAM is not being managed efficiently. Steps to diagnose: use performance monitor to check available bytes and pages counters, check for memory leaks in Task Manager by identifying processes with high memory usage. Common causes: insufficient RAM for running services, memory leaks due to poorly designed applications. Solutions: increase physical RAM if required, close unnecessary applications or services, use Task Manager to close memory hogging processes. 3. Disk space and I/O bottlenecks. Insufficient disk space or excessive disk I/O can significantly degrade system performance. Steps to diagnose: use Task Manager to check for processes that are heavily reading from or writing to the disk. Use Performance Monitor to check disk usage and I/O performance counters. Common causes: running out of disk space, fragmented disk or hardware failure. Solutions: clear unnecessary files, including temporary files, log files, and system backups. Run chkdsk, which is check disk, to check for file system errors or bad sectors. Defragment the disk to optimize disk performance. 15.4 Recovery from system failures. System failures can occur for a variety of reasons, including hardware malfunctions, corrupt system files, or even security breaches. Windows 2000 offers several recovery options, from using built-in tools to performing complete system restores. 1. Safe mode. Safe mode is a diagnostic startup mode that loads the minimum set of drivers and services. It's useful for troubleshooting issues that prevent the server from booting normally. How to use: restart the server and press F8 during boot. Select safe mode to load the system with minimum drivers. Common uses. Troubleshoot driver-related issues. Resolve problems caused by recently installed software or updates. 2. System restore and repair. Windows 2000 provides repair tools that can restore the system to a working state in the event of a failure. How to use: boot the Windows 2000 installation CD, select repair, and initiate a repair installation or recovery console for manual recovery. Common uses: restore corrupted or missing system files, repair boot-related issues caused by configuration changes, restoring from backups, or backup, Restoring from a backup is often the best way to recover from data corruption or hardware failure. Windows 2000 supports several backup solutions, including using backup utility or third-party tools. Steps to restore: use backup to restore system state or data from a previous backup. If the backup is located on a network share, ensure network connectivity is restored. To reduce frequency of troubleshooting and recovery scenarios, it is important to implement preventative measures. 1. Regular backups. Schedule regular backups of critical data and system state. System monitoring. Continuously monitor system performance and logs to detect issues before they cause major disruptions. Patch management. Keep the system and software up to date with the latest patches and service packs. Security practices. Implement strong security practices to prevent unauthorized access and potential breaches. Summary: Troubleshooting and recovery are critical skills for any system administrator, and Windows 2000 provides a variety of tools and utilities to assist in diagnosing and resolving problems. From performance issues to hardware failures, administrators can leverage tools like Event Viewer, System Monitor, and Task Manager to identify and address root causes. Additionally, understanding recovery options like safe mode, system restore, and backup is essential for ensuring business continuity in the case of a system failure. By following best practices and proactively managing system health, you can minimize downtime and ensure a stable, reliable server environment. So in the next chapter, I'll cover security best practices. So I'm going to leave it here for today. I hope you like listening and spending time with me. So thank you again.